All right, this is pre-calculus section 1.1, and we are going to be looking at lines in the plane, both graphing and being able to write equations, parallel lines, and perpendicular lines. All right, here's what we've got. You should be on page 1 of your packet. The first example is just asking us to sketch the graph of the following equation. Well, both of these equations are linear equations. You can see they're the first one here is in slope-intercept form, so if I'm going to graph that, one of our main methods of graphing is graphing in slope-intercept form. All right, so we've got my y-intercept, so this is your y-intercept, and that is 1. And I've got my slope here, this is your m, 2/3, so I'm going to go up 2 and over 3. It's a rise to run, up 2 over 3. You do the y's first, then the x's. You might want to do the slope a couple times. I can also go down 2 to the left 3, and it represents the same slope. All right, and right there's my linear equation, my line, the graph of this linear equation. All right, second example, it's in slope-intercept form again, so let's go ahead and plot it. We've got my x and y axis. You can see here that my y-intercept is -1, so go down 1 unit, put the point. My slope is -2, so down 2 to the right 1, you can see it has a negative slope, it's falling, or I can go up 2 to the left 1, it does the same thing. And whoops, let's try to do that again. And there's my line. All right, now this is the best method that we have for graphing linear equations. You'd want to put your equation into slope-intercept form, and to do that, all you need to do is solve your equations for y, and you'll have the results. All right, this is another form of our equation, the point-slope form of the equation. Here we've got y minus y1 equals m and x minus x1. These parts are the important ones. Your x1 and y1 is it's the point part of it. Okay, and your m here is the slope part of the form. And so this form we use to write equations of lines if you're given either a point and a slope, or if you're given just 2 points. All right, so looking at example 2 here, find the slope-intercept form of an equation. So we're looking to write the equation into this form, mx plus b, of a line with slope of 4, passing through the point -6, 2. So we go, here's our equation, y minus y1 equals m times x minus x1. By using this equation, all we have to do is substitute. So y minus the y value is 2, slope is 4, and x minus a -6, well, minus a -6 would be plus 6. I'm going to go ahead and make that change in signs right away. Y minus 2, let's distribute the 4, so it's 4x plus 24. And last step, add the 2 over, so 4x plus 26. That is the equation of the line using your point-slope formula. All right, second part to this example, it says find the slope-intercept form of a line that passes through the point 4, 5 with the indicated slopes. All right, well, what does it mean to have a slope of 0? Slope of 0, it's a flat line, so it's horizontal. Okay, I could use my equation y minus the y is 5 equals the slope is 0 times x minus 4. Well, all we get here is y minus 5 is equal to 0. So then y would equal 5. If you remember to write a horizontal line, it's always y equals, and you can see here that the y value from the point is 5. So that's how you would write a horizontal line. So y equals 5 is the answer to part A. Part B, slope is 3, so we're going to do the substitution, y minus the 5, 5 coming from your ordered pair, 3 is your slope, and then I would have my x minus the 4. The only thing that I changed from the substitutions is my slope. So this is y minus 5 equals, distribute the 3, which you get 3x minus 12. And if I add the 5 over, y would equal 3x minus 7. So this is your linear equation for part B. All right, last one, undefined slope. An undefined slope means that it's vertical. We are not able to use the point slope formula for this. So what you have to do is, let's just look here. If I plot the point 4, 5, it's right here. So if I don't have a slope, that would be a vertical line passing through that point. So what's the equation of this line passing through the point at 4, 5? Well, vertical lines, if you can remember, we use x equals, so we just need the x value here. The x is 4, so x equals 4 is the equation for that line. All right, so you're going to need to know when you have slopes of 0, undefined, vertical lines, horizontal lines, and being able to write any sort of equation of a line. All right, example 3, a company purchases a $20,000 machine. In 4 years, the machine will be worth $10,000. Write a linear equation that gives the value v of the machine after t years. So we're looking for v equals, using t for my variable. Well, if in 4 years it went from 20,000 to 10,000, we need to figure out what's the decrease per year. Well, the difference here, the difference is 10,000. So you take 20,000 minus the 10,000. That's going to give you the difference, how much the machine went down in value. And for every year, so if we divide by 4, then we're going to get 2,500. This is the rate of decrease, and the rate of decrease is your slope. Okay. We also have this right here is our initial amount. So an initial amount is an ordered pair, or your 0, 20,000. This ordered pair is like at 4 years you have 10,000. So you could do it this way as well. Find some ordered pairs, figure out your slope, and then use your y-intercept. So you've got, you start at 20,000, and now you're decreasing because it's going down 2,500 per year, and since they want us to use t, we're going to use t for the number of years, and there you have it. Now you might be asked some specific questions like, well, what would it be worth after 6 years? And those calculations you could just substitute in for t for the number of years. All right, we are still on page 1 of your packet, and just some basic information here, reviewing parallel lines and perpendicular lines. Parallel lines are obviously 2 lines that don't cross each other, and they're also going to have the same slopes. So 2 distinct non-vertical lines are parallel if and only if their slopes are equal. And 2 non-vertical lines are perpendicular if and only if their slopes are negative reciprocals. I'm going to list some examples of opposite reciprocal slopes. So if I have a slope of 2, then it's perpendicular to a slope of negative 1/2. If I have a slope of 5/3, it's perpendicular to a negative 3/5. And of course we also have 0 slope is perpendicular to an undefined slope. So that's just a little bit of review on perpendicular and parallel lines. Now we're going to use that information to write some equations. Here's another form that we're going to be looking at. It's called general form. General form, you have all your x's, y's, and your constant on the left side, and you're setting it equal to 0. So a, b, c are all integers, and a and b could not be 0, because if that was the case, then you wouldn't have any variables. You would just have a constant like 5 equals 0. Okay, so these all have to be real numbers or integers. Example 4, find the general form of an equation of a line that passes through the point 1, -3 and is, so part A, parallel to, and part B, perpendicular to this line. Well, what we need to do for this line is, in order to figure out parallel and perpendicular, we need to figure out the slope of the line. So to find the slope of this line, I'm going to solve it for y and put it into slope-intercept form. Subtract the 2x, -2x plus 1, and divide by 3. -2/3 x plus 1/3. So here's my slope, -2/3. That's what we identified as being our m value. Okay. Another way that you can find slope, knowing that in standard form here, if you solve for your y, it's always going to be the opposite of a over the b value. Okay, or the opposite of capital A, which is the coefficient of the x, divided by capital B, which is the coefficient of the y. That's another way to find your slope. All right, let's do it. Okay, let's find our equation of our line. We are dealing with the point 1, -3, and slope is -2/3 here. So you start off by doing, for parallel, y minus, the y value is -3, so it's y plus 3, equals -2/3 times x minus 1. We're going to distribute y plus 3 equals -2/3 x plus 2/3. One issue that we have here with this problem is we've got fractions, and so I'm going to eliminate those fractions. You can do that by multiplying both sides by the least common denominator, which is 3. And let's see what we've got left. We've got 3y plus 9 equals -2x plus 2. By multiplying both sides by 3, you eliminate the fractions. All I need to do now is put everything to the left side, so I'm going to move my 2x's over, so that's 2x plus the 3y, and also move the 2 over. 9 minus 2 is plus 7 equals 0. Here is my equation in the general form. All right, we're going to do the same thing here for perpendicular, and you're going to see here that I don't have to do a whole lot of difference in substituting. What I do have to change is I have to change what I'm substituting for my slope. So maybe this will give us a little bit of room here. I've got my slope, so I've got y plus 3 again, because it's y minus -3 equals, my perpendicular slope would be 3/2 times x minus, and it was 1. We're going to distribute the 3/2. Y plus 3 equals 3/2 x minus 3/2. This time, I'm going to multiply both sides by 2 in order to eliminate the fractions. And by multiplying both sides by 2, I've got 2y plus 6 equals 3x minus 3. Move the x's over, -3x plus 2y, and move the 3 over. 6 plus the 3 is 9. You may also see equations written with your leading coefficient being positive. So if that's the case, it would be 3x minus 2y minus 9 is equal to 0. Okay, so there's your equation of your of your line. And both of these are equations. It just depends on, whether or not they're wanting the leading coefficient to be positive. All right. We've got just some general forms here for you to look at. We've got the general form we just talked about, a vertical line, x equals a horizontal line, y equals b. We know the slope-intercept form. And now we've been using the point-slope formula. So all of these formulas are formulas that we will be using. And that is it for this first section. Here is your assignment on page 12.